Suppose the mean is 36, then the median is 40, then the mode is 50, then such kind of a data we call it as the skewed data or asymmetrical data. In absolute measure, it gives the exact measurement of the difference between the mean, median and mode, whereas in case of relative measure, they are expressed as percentages. How do we calculate the mode? So 3 median minus 2 mean, we get the mode value. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session, we will be having a discussion on measures of skewness. This is the third part of the Unit 2, wherein we will be studying about what is skewness. So, measures of central tendency reveal the pattern of data with a single numerical value which represents the entire data. Now, in the measures of central tendency, we have the mean, median and the mode, and all these, so one numerical number, it represents the entire data. For example, if you take the example of the mean or the average, what we call, so it is a representation of the entire data. So if you want to have a division of the data, then median represents that. And if you want to have the data with the highest frequency, then we have the mode. So one single numerical value will describe the entire data. And measures of dispersion examine the variability in the data, how individual observations are spread from its central value. Now, if you can see here, in the measures of dispersion, we will be just studying about the variations in value. So, range. So, we just calculate the range. We calculate the standard deviation. We calculate the mean deviation. We calculate the quartile deviation. So, all these things are there to help us to know what are the variation between the values. So, what is the variation between Q3 and Q1? What is the variation between Q2 and Q1? So, all these things we will be learning in measures of dispersion. So, based on the values of the mean, median and mode, we can understand whether the distribution is symmetrical or asymmetrical. So, this kind of a measures of dispersion, it tells us whether the given data is symmetrical in nature or asymmetrical in nature. Now, let us look into what is the definition here. When a series is not symmetrical, it is said to be asymmetrical or skewed. Now, when the series are uniformly distributed, then we can call it as a very good symmetrical data. But if the series is not distributed uniformly, then we call it as asymmetrical or skewed data. A distribution is said to be skewed when the mean and the median fall at different points in the distribution and the balance or center of gravity is shifted to one side or the other, to the left or the right. So, when we are calculating the mean, median or mode, we observe that almost all the values, they try to center around a particular data. Suppose the mean is 36, then the median may be 36.5 and the mode may be around 36 or 37. So, they are all just very close to each other. But then, if you find a distribution or a table where the mean, median and mode varying in value. Suppose the mean is 36, then the median is 40, then the mode is 50, then such kind of a data, we call it as the skewed data or asymmetrical data. Now, in such data, we can see that the center of gravity, so it will fall to one side. So, in a distribution, if mean, median and mode coincide, the distribution is said to be symmetrical. If they are of different values, the distribution is said to be skewed or asymmetrical. Now, if you can have a diagrammatic representation of the skewness, so you can see here in this distribution of data, we have the mean, we have the median here and the mode here. So, if you can see here, this is the center of gravity and almost all the mean, median and mode, they are at different points. So usually we don't find such differences in the mean, median and mode, and they are falling to the left side of the center of gravity. So we call it as the negatively skewed. Now, in the normal, if there is a normal distribution of data, then the mean, median and mode, they will all be in one single point. So there is no skewness in this data. And if you can see, the diagram is a perfect bell-shaped diagram. Now, in this case, here we have this positively skewed data. So, the mean is here, median is here and the mode is here, and almost all the values, they are falling to the right side of the data. So, this kind of a data, we call it as the positively skewed data. Now, as shown in the diagram A and C, in case of a skewed distribution, the following points can be observed as tests of skewness. So, the mean, median and mode have different values. So, if we can see here, so here there are different values for mean, median and mode. Even in this, see, this is the A diagram and this is the C diagram. So, here also they have different values for mean, median and mode. Then quartiles are not in equal distance from the median. Then the curve showing the distribution is not bell shaped. If you can see here, this is the perfect bell shaped diagram. But here if you can see, this is not bell shaped. So here also there is no bell shape in this curve also. Then the observations are not distributed equally from the mode. The sum of positive deviations from the median is not equal to the sum of negative deviations. Now if we have to have a median deviation, then we can see that the sum of the positive deviations is not equal to the sum of the negative deviations. So all this, we can say that whatever the data given has been skewed. Then next, the types of measures of skewness. So as in the measures of dispersion, there are two types, that is absolute and relative. So absolute measures indicate the skewness in original terms in which the data is collected, which may not be useful in comparison, whereas relative measures are expressed as percentage or ratio, so that comparison is possible. So they are known as the coefficient of skewness. Now absolute measure means the exact measure. So in case of this, whenever you are measuring the measure of skewness, so you can measure it in two types. One is the absolute measure, one is the relative measure. So in absolute measure, it gives the exact measurement of the difference between the mean, median and mode. Whereas in case of relative measure, they are expressed as percentages. How far the mean is from the median or how far the mode is from the mean. So they will be expressed in percentages so that comparison will be easy. Then differences between dispersion and skewness. Now in this unit 2, we have just studied about what is dispersion and what is skewness. Now let us what are the differences between dispersion and skewness. So dispersion indicates the amount of variation, whereas the skewness indicates the direction and the extent of variation. So in dispersion, we can see that we can just calculate the amount, we can measure the amount of variation, whereas the skewness indicates the direction. In skewness, we will know whether it is a positive or negative skewness. So the measures of skewness are depend on measures of dispersion. Unless we know the measures of central tendency and measures of dispersion, we cannot compute the skewness. So the measures of skewness are dependent on measures of dispersion. So until and unless we calculate the measures of dispersion, we cannot calculate the measure of skewness. Then there are four measures of skewness. So first one is the Karl Pearson's measure of skewness. Second one is the Bowley's measure. Then we have the Kelly's measure, and then we have the Moment's measure of skewness. Now for your syllabus, we have only two measures, that is the Karl Pearson's measure and the Bowley's measure of skewness. Now let us see what is this Karl Pearson's measure of skewness. Now The Karl Pearson has developed this coefficient and hence it is known as Pearsonian coefficient of skewness. So, Pearsonian coefficient of skewness. So, it says that the absolute measure is the difference between the mean and the mode. So, when you have to find out the value of skewness, it says that you just find out the difference between the mean and the mode, we get the skewness. So, its relative measures is obtained by dividing the absolute measure by standard deviation. So, when you just divide the difference between the mean and the mode divided by standard deviation, then we get the relative measure of the skewness. So, the skewness, if you want to know just the skewness, you can always just find out the difference between the mean and the mode. Now, in the coefficient of skewness, we have the mean minus mode divided by standard deviation. So, this we can also write in the form of mean minus mode divided by standard deviation. So, here this x bar represents the mean, the z represents the mode and this rho represents the standard deviation. Or we can also have one more formula here. The Karl Pearson skewness of measure can be done by 3 into mean minus median divided by standard deviation, or we can calculate the mode. How do we calculate the mode? So, 3 median minus 2 mean, we get the mode value. Mode equals 3 median minus 2 mean. So, if you don't know how to calculate the mode, so 3 times the median minus 2 times the mean, we get the mode value. Now, we have a problem here. Compute coefficient of skewness for the following data. So, they have given the salaries and the employees here. So, I will write the data in the vertical form here. So, this is the x values and this is the frequency. So, I write 20, 30, 40, 50, 60, 70, 80. Now, we have the frequencies 4, 14, 22, 30, 20, 8 and 2. So, first thing, whenever we have to find the skewness, we have to find the measures of dispersion. So, first thing is, I will just find the mean, then I have to find the mode, then I have to find out the standard deviation. So, if I have all this, then I can always find out the skewness of this. So, what is the formula for skewness? SKP equals mean minus mode divided by standard deviation. Now, I have to calculate the mean here. So, how do I calculate the mean? F into x, Fx. So, 20 into 4, 80, 420, 880, 1500, 1200, 560 and 160. Now, you add all the values, you get Fx, sigma Fx, mean value will be equal to now what is the n here? 14 plus 4 18, 18 plus 2 20, 40, 40 plus 30 70, 90, 100. So, sigma Fx will be equal to 0, 6 plus 6 12, 12 plus 8 20, 30, 0, 3, 4 plus 3 7, 7 plus 8 15, 15 plus 5 20, 20 plus 2 22, 22 plus 5 is 27, 28. So, it is 4800. So, this will be sigma Fx equals 4,800 divided by 100. So this is equal to 48. So we got the mean value as 48. Now we have to find the mode value. So the mode value will be the value with the highest frequency, that will be 50. And now I will find the D. Now what is the formula for standard deviation? The standard deviation formula will be root of sigma FD square divided by n minus sigma FD by n the whole square. So this is the formula here, sigma FD square divided by n minus sigma FD by n the whole square. So D will be equal to x minus mean, x minus 48. So in 20 minus 48 minus 28, 30 minus 48 minus 18, 40 minus 48 minus 8, 50 minus 48, so that will be 2, 60 minus 48, 12, 70 minus 48, 22, 80 minus 48, that will be 32. So this is D column. See, we have the mean here. So we calculate the standard deviation will be root of sigma FD square divided by n. Yes, now if we can see here, so we have the D square column here. 28 into 28 is 784, 18 8s are 18 into 18 is 324. So in this way we calculate the D column. Now FD square. So if you can see here, we are multiplying the frequency into the D square. So I get FD square as 18,000. Now standard deviation will be root of 18,000 divided by 100. So the root of 180, that is 13.42. Now if I have to find the skewness, so it will be 40 minus 50. So what is the, how do you calculate the mode? Mode is the value with the highest frequency. So the value with the highest frequency is 50. So this becomes the mode of the frequency of the table. So 48 minus 50 is minus 2 divided by 13.2. I get minus 0.149 or minus 0.15. So this you have to calculate in this manner. Next, given the following data, calculate the Karl Pearson's coefficient of skewness. Now, in this formula, they have already given the sigma x, n, then sigma d, t square and the mode. Now, we have to calculate the s, k and p. Now, I first write the formula for skewness. The Karl Pearson's coefficient of skewness formula is mean minus mode divided by standard deviation. So this will be equal to mean minus mode, or I can write the mode as Z, divided by standard deviation. Now I have to find the value of mean. So they have given me sigma x divided by n. So the value, the formula for mean is sigma x divided by n, that is 823 divided by 5. So this, what will be the answer? So 5 ones are 5. So 5 6 are 30. 5 4s are 20. 5 6 are 30. 164.6. This becomes the mean value. Now I have to find, they have already given me the mode value is 163. Now I have to find out the standard deviation. So standard deviation will be root of sigma d square divided by n minus sigma d divided by n the whole square. So this will be equal to the root of sigma d square. Sigma d square is 350 by 5 minus the sigma d. This will be 8 by 5 the whole square. So when I simplify this, I get 1.6 the whole square. So 70 minus 1.6 the whole square, I get root of 67.44, that comes up to 8.21. Now I substitute the values in the formula here. So 164.6 minus 163 divided by 8.21, I get 1.6 divided by 8.21. So this is 0.195. So I can say that there is a very low positive skewness. So I come to the conclusion. So since the value is in a positive number, I say that this given data is positively skewed. Now we have one more problem here. The marks are given here 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90. Then the number of students also is given. So we'll write down here in the next slide. The marks are given as follows. So it is 40 to 50 up to 100. So 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. Next, we have the number of students. So the number of students are 50, 80, 125, 220. 50, 80, 125, 220, 175, 100. So we have the data here. Now we have to find the marks achieved by 750 students in an examination. Find out the coefficient of skewness. Now we have to find the coefficient of skewness of this given data. So I have written down the data here. The next step will be I have to find out the mean values. Then I have to find the mean. Then I have to find out the mode. And I also have to find out the standard deviation. So all this I have to find out. Now if I have to find out the mean, the first thing will be I have to find out the mid value. Now what is the mid value here? So between 40 to 50 it is 45, 55, 65, 75, 85, 95. Mid values. Now if I have to find out the mean, I have two methods. Either I do f into m and find out the values, or I have one more method, that is take the help of the assumed mean. So d will be equal to now if I take 65 as the assumed mean, so m minus 65. So this will be the d value here. So 45 minus 65 minus 20 minus 10, 0, 10, 20, 30. So we have all these values here. So in order to calculate the mean, I have taken the assumed mean as 65. So d minus 65, that will be 45 minus 65 is minus 20, minus 10, 0, 10, 20, 30. Now in order to simplify this, I just divide the entire column by 10. So I get minus 2, minus 1, 0, 1, 2, 3. Now d square will be 4, 1, 0, 1, 4, 9. Now f into d will be frequency into deviation. So 50 into minus 2 is 100, 80 into minus 1 is 80, 125 into 0 is 0, 220, 350, 300. So the same way I find out the fd square. Now I have to find out the mean. So the mean will be equal to a plus sigma fd divided by n into h. So this will be, what is the assumed mean here? 65 plus sigma FD. Sigma FD will be 690 divided by 750 into 10. So when I simplify this, I get the answer as 74.2. So this is the answer for mean. Now I have to calculate the mode value. Mode will be equal to F1 minus FO divided by, so this will be L plus 2F1 minus FO minus F2 into I. So I have to identify the mode. So the mode is the value with the highest frequency, that is 220. So this will be the modal class. So the lower limit of the modal class is 70. So I write mode equals 70 plus F1 minus FO. So what is the frequency here? So this will be F1, this will be FO, this is F2. So the frequency of the modal class is 220 minus 125 divided by 2 into 220 minus 125 minus 175 into 10. So when I calculate this, I get the mode value as 76.8. Now I have to find the standard deviation. The standard deviation formula will be root of sigma FD square divided by n minus sigma FD by n the whole square into I. So standard deviation will be root of sigma FD square. So 2100 divided by 750 minus 690 by 750 the whole square into 10. When I simplify this, I get root of 1.9536 into 10. The root of 1.9536 is 1.398 into 10, that is 13.98. Now to calculate the SKP, I have 74.2 minus 76.8 divided by 13.98. So minus 0.19. So this is a negative skewness. There is a very low negative skewness in this kind of a data. With this, we come to the end of this session. Hope you have all followed it. Thank you.